So this is the circuit analysis. So in this circuit, if the given are Vs is equal to 5 volts, the R1 is equal to 1 kilo ohms, R2 is equal to 2 kilo ohms, R3 is equal to 3 kilo ohms, and R4 is equal to 4 kilo ohms. Find the V1, V2, V3, I1, I2, and I3. So first, we're going to solve the total resistance. So total resistance is equal to 1 kilo ohms plus 1 over 2 kilo ohms plus 1 over 7 kilo ohms raised to the power of negative 1. So it is equal to 2555.56 ohms. Next is the total current. So total current is equal to Vs over RT. So Vs is equal to 5 volts, then total resistance is equal to 2555.56 ohms. So it is equal to 1.96 milliampere or 0.00196 ampere, or in fraction 49 over 2500 ampere. So total current is also equal to I1. So next is VR1. So VR1 is equal to I1 times R1. So the I1 is equal to 1.96 milliampere times R1 is equal to 1 kilo ohm. So it is equal to 1.96 volts. So next is solving the V1. So in this circuit, the V1 is equal to Vs because there is no resistance in this circuit. So V1 is equal to Vs, so it is equal to 5 volts. Next is V2. So V2 is equal to Vs minus VR1. So Vs is equal to 5 volts, then VR1 is equal to 1.96 volts. So it is equal to 3.04 volts or 76 over 25 volts. Next is I2. So I2 is equal to V2 over R2. So V2 is equal to 3.04 volts, then R2 is equal to 2 kilo ohms. So it is equal to 1.52 milliampere or 0.00152 ampere, or in fraction 19 over 12,500 ampere. Next is I3. I3 is equal to I1 minus I2. So I1 is equal to 1.96 milliampere minus I2 is equal to 1.52 milliampere. So it is equal to 0.44 milliampere or 0.00044 ampere, or in fraction 11 over 25,000 ampere. Next is solving the VR3. So VR3 is equal to I3 times R3. So I3 is equal to 0.44 milliampere times 3 kilo ohms of R3. So it is equal to 1.32 volts. Next is V3. So V3 is equal to V2 minus VR3. V2 is equal to 3.04 volts minus VR3 is equal to 1.32 volts. So it is equal to 1.72 volts, or in a fraction 43 over 25 volts.